Hello, grade 12s. Welcome back to the channel, Science Therapy, hosted by the one and only science therapist, Uabudewa Sos, Ugobela Wemets. And without any further ado, let's look at these questions that we have here. Ah, Okay, so we have question 9 on electrodynamics. It says, study the diagram of a simple generator below and answer the questions that follow, right? So we are given the simple generator diagram here. And then 9.1, it says, is this an AC or DC generator? Give a reason for the answer. Now, looking at the fact that these ones are what we call slip rings, we can say this is an AC generator. So we are going to say AC generator, and then the reason for that, it has slip rings. All right. And then 9.2 says, state the energy conversion that takes place in this generator. We know that in a generator, it is always mechanical energy to electrical energy. So we are going to say mechanical energy to electrical energy. Right, and then 9.3, in which direction will the induced current flow? State only from A to B or from B to A. Now remember, I said with the generator, if the rotation of the coil is clockwise, also the current will move clockwise. If the rotation of the coil is anti-clockwise, also the current is bound to move anti-clockwise. So the only time we have a change in that is when we are working with a motor. But then here, as we can see, the rotation is clockwise, meaning the current is also flowing in a clockwise direction. So like that. And then this will be moving from point A all the way to point B. So for 9.3, we are supposed to say from A to B, right? And that's it. Now, we are not done. Still have to move to other questions. It says the diagram below shows the EMF time graph for one complete rotation of the coil. Then calculate the resistance of the load RL if the value of the IRMS is 4.55 amperes when the Vmax is 150 volts. Right. So remember, we cannot calculate the resistance with while we still have the Vmax here. So the first thing that we should do is try to calculate VRMS from that Vmax. So VRMS is equals to Vmax over root 2, right? And then this is going to be 150 over root 2. And then when you punch that into your calculator, you will get 106.066 volts. So I'm just going to round off to 3 decimal places. And then to calculate the resistance, now I can say this is R is equals to VRMS over IRMS. Now the VRMS 106.066, and then the IRMS is the one that has been given here, which is 4.55. And then when you punch that into your calculator, you get 23.31 ohms, right? And that's it. Easy peasy. So let's indicate that was for 9.4. Right. Now, load RL is now replaced with a bulb with a power consumption of 400 watts. Assume that the bulb is 100% effective and calculate the light energy emitted by the bulb in 3 minutes. So we know that our time should always be given in seconds. So immediately we say multiplied by 60 there. Now, obviously, we are given the power here, and then we are supposed to calculate the energy. So we do know that energy is just a product of the power and the time, right? So energy is P multiplied by delta T. If you can look at all those formulas, those are formulas of power and then multiplied by delta T. So your power here, you are already given, it's 400, and your delta T, you are going to say 3 multiplied by 60, so that it is in seconds. And then when you just punch that into your calculator, you get 72,000 joules. Now, this is a 3-mark question, supposed to be a straightforward question, formula, substitution, and the correct answer. Right. Now, we have 9.6, it says that the speed of rotation of the coil is now doubled. Redraw the above diagram in your answer book. On the same set of axes, indicate the old and the new pattern obtained. Label the new pattern B, right? So let's start. So this is what we are going to have. So remember, we must redraw the old one. So the old one is like that. And then it has 0.2 here. And then maximum at 150. So you can indicate this is EMF in volts. And then here, this is time in seconds, right? So now we must indicate the other graph that will be obtained if we double the speed of the rotation, right? Now, according to this, the formula that we have, we know that the operation of a generator is based on Faraday's law, right? So if we are to increase the speed, we know that we are decreasing the time. So if you increase the speed, you are actually decreasing the time. And then we know that EMF is inversely proportional to delta time. So a decrease in time will lead to an increase in EMF. So if we are actually doubling the speed of the rotation, that means we're halving the delta time and then therefore doubling the EMF. So what must happen here is that within this time, this is 0.1, right? So this is the time it takes to complete half a cycle. But now this will be the time to complete the full cycle. And then now your EMF will go all the way up until there. I'm going to try to curve it somewhere closer there. And then there we go. Right. So not very nice, not very nice. So it's supposed to go like that. Okay, but then you get the whole point, right? That's it. Not very good when it comes to drawing, guys. Okay, so this is what we have now. So that means now the maximum will be at 300, right? So that point there is supposed to be at 300 because now there's a doubling of the EMF. But now again at the same time, what it took this cycle here to complete in 0.2 seconds, it only takes this cycle here to complete in 0.1 seconds. So the full cycle will be in 0.1 seconds as opposed to this one because the speed of the rotation was not doubled yet. So this is how you were supposed to indicate that. And then we are supposed to indicate that this is pattern B, right? So the blue one is pattern B. So this one here, the red one, will be representing the old one. Again, it is very important that you show that the EMF has now been doubled, right? EMF has now been doubled. So here it's 150. And then the time has been halved and the EMF doubled. Okay, so 9.6.2, they say with what factor will the energy emitted change if the speed of the rotation of the coil is doubled? Now it is 2 times faster. Explain the answer, right? So again, if we are to explain that, so you can either explain it in words or you can explain it by a calculation, right? Now let me try to explain it in words and then thereafter we'll calculate to prove. So now we know that it will double with a factor. I mean, it will increase with a factor by a scale factor of 4W. And then why? Because our EMF is inversely proportional to delta time for a constant number of turns and change in magnetic flux. So I'm basing this on the formula for the Faraday's law. So we know that E is inversely proportional to delta time if we keep the number of turns and the change in magnetic flux constant, right? Then number 2, if rotation doubles, the induced EMF will also double, as we saw there with the drawing. So if rotation doubles, the induced EMF will also double because we are actually halving the delta time, right? But we know that the energy W is directly proportional to V squared, according to which formula W is equals to V squared over R and then times delta T. Right. According to this formula, we know that the energy is directly proportional to V squared. Right. For a constant, delta time and resistance. Right. So now, since remember EMF is voltage, then what will happen here? So if the energy emitted will quadruple, right? Okay, so by calculation, you would simply state this. You would first use the formula E is equals to negative N, and then change in phi over. Now, what happened to delta time? Remember, if you are doubling the rotation, you are actually halving the time because of the relationship between speed and time. We know that speed is inversely proportional to time. So a doubling of the speed means a halving of the time. So that means here I will have half delta t. And then my E is going to be negative 1 divided by half. This is negative 2. And then N delta, and then delta T, right? But then remember, all of this is standing for EMF, right? So all of this can be replaced by EMF. So that means the new EMF now is going to be 2E, right? So 2E. So this is our voltage. Our voltage is 2E. And then we can then go to this formula, W is equals to V squared over R and then delta T, right? So in this position here, we do understand now that this one can be represented by 2E, but then EMF can also be taken as the voltage because EMF is just the voltage. So let me write it as V is equals to 2V. Then where there is V, I'm going to substitute 2V. Then I have square over R and then delta T. Remember, I'm keeping R and delta T constant this time around. This will give me 4 and then V squared delta T over R. But then remember, all of this can be taken as W. So that means this will be equal to 4W. So that would be the calculation to actually prove that the energy quadruples. So first, the EMF doubles, and then the energy will have to quadruple. Right, so that's how you were supposed to go about answering that question for a total of 17 marks. So it was a very nice question again. Only thing that could have given you a challenge would have been this question here, 9.6.2. But then with a few more practices, then you will be able to understand such questions. These are more of your higher order questions, those questions that they put in there, just so that to make sure that you don't get 100%. But then either way, we are still smashing that 100%, just like the working of the bulb here. So, okay, so keep on practicing. With all that being said, guys, please press the thumbs up button if you have enjoyed the lesson and then you found it helpful. And if you've been watching the videos and haven't subscribed yet, please hit that subscribe button. But most importantly, please share the link with your friends and classmates so that they may also find assistance. Remember, do not be selfish. We are winning as a team.